Hello, so continuing on this weekly contest 341, the third problem, minimum addition to make a valid string. So for this problem we get a word and we can insert any of these three letters, A, B, C, anywhere and any number of times. But the goal is to return the minimum number of letters that we have to insert to make this word string valid. Now, what do they mean by valid? Well, valid means that it has to be a concatenation of the string ABC several times. Okay? So let's take this first example. We have just B. So to make it a concatenation of, the minimum way to make it a concatenation of ABC is just to have ABC by inserting A in front of B and C after it. So we need to insert two letters, and so we put 2 here. Now with these 3 A's, well, the minimum way is to insert BC for this A, for the first A here, and then to insert another BC for the second A, and then another BC for the third A. And so BC multiplied by 3 for each, that's 6. Yeah, so that's pretty much what the problem is. Now the length of the word is really small, 50, and the word itself is going to have only ABCs. We don't need to worry about extra letters making it impossible. So how do we tackle this? Okay, so let's see how we can tackle it. So we know that anytime we see a portion of ABC, right, that is not complete, then we need to complete it so that we can get a concatenation. We are looking for the minimum number of letters we can add. So for example, here, when we see this A, we continue and see a different A that is different than B, which is expected to get ABC, then that automatically means we need to insert B and C. And so we know we need to insert B and C here. Now we look at this other A. Now A again, the next one is A. So that means it's not B. We won't find B, so we need to insert BC. And then of course, why we insert C? Because also we see that C is not the next character, so we have to insert it. And then we have this A at the end, there is nothing, and so we have to insert BC to get ABC. And now this string is going to become ABC, 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 which is valid because it's only a concatenation of ABCs. So how many we had to add? 3 here. So that's sort of the problem. Now you can see here, when we encounter a different one, we are forced to insert. Okay, so what we can do is actually just do that behavior. And basically so with AA, we'll traverse these characters. So the first one is A, and we have this string, let's call it S, that is ABC. And so what we have to do is, while the expected value that we expect at S, so we will keep an index for S, we will keep an index to track where do we match. So first our I is at the first position, let's call this I, and let's call this J. So first we need to make sure, while the first one will match, and so since they match, we will move I and we will move J. Okay, but now since they don't match, while they do not match, right, this would be the word at index J. So while they do not match, what should we do? Well, we have to insert. So first B doesn't match, so we have to insert B. Now if this was C, we don't need to insert C, but since it's not, this while will need to run again and insert C, right? And so here, since first B is not here, B is not at this next position that we want to, we have to insert. And so what does that mean? Inserting means we have to insert 1 letter, so we increment the count. Now we don't know yet if we will find C or not. We don't know, we haven't checked. We only know that this next character is not B, and so we need to insert B. And then we need to advance our pointer I here. Okay, so we need to do I plus 1. But the other thing is, remember, we need to have concatenation of ABCs. So once we reach the end, what should we do next? Well, we should reset I to 0 because we need to look for the next ABC as long as this word still has letters. And so what this means here is that to go from 3 back to 0, we need, when we increment I, we need to actually do it modulo 3. because the length of the string is 3. So this actually needs to be I plus 1 modulo 3. Okay? And then what do we want to do here? J is going to be just going through the length of the word that we have. Okay? Because that's literally what we are doing. We are traversing word. And then once they are equal, right? So let me actually just move this down. Okay? And so now we'll find that we insert B, we count it, and then we move our pointer to C here. And our pointer G will stay because we have this while loop. And now we'll check, is C equal to this A in this while loop? It's not. So that means we need to insert this C. And so we increment our count by 1 again. And so our count is now 2. Okay? And now they are equal. And so when they are equal, because we move our I again, but with this here, with this modulo, it will be here again. So now A equal to A. Okay? And so that's why when they stop being equal, when they are equal, what should we do next? Well, we should just move both pointers. So we move this pointer here, and we move this pointer to the next one here. But for moving this J, this for loop takes care of it, but we need to do this move here. And so we need to do that move, which is the same way, going to be I plus 1 modulo 3, because we don't know, maybe it was at the end. Okay? So this is going to be after the while loop. And now we'll check again, is this B equal to this second A? Because we just saw an A, so we expect a B, but it's not, and so we need to add it. And so that means we need to insert a B here. And so we increment our count, and we move our I pointer now to C. Okay? And now when we move our I pointer, is it the same? C equal to A? No, it's not. So we need to insert C again here. Okay? And so now now our count is going to be equal to 3. And so again, we increment our I to this here, and now they are equal. Okay? So now that they are equal, again, we move our J, and now our J is outside. So so this loop is done. Okay? But we have an I, and so we increment, we have incremented this because of this instruction here, and now it's at B. But the problem is that we haven't, so this is 0, 1, 2. The problem is we haven't inserted the B and C here, and so we have to do one more check after this for loop to check if I is different than 0. That means we found a partial match for this ABC. That partial match may be AB, it may be just A. And so if I is different than 0, that means we already found a partial match, and so we need to continue to get an ABC at the end here. And so how do we say that? Well, we just need to insert BC, and so we just need to increment our count by how many characters are remaining. Now, how do we find that? Well, we know the string length is 3, and we already inserted up to I. Okay? And so what does that mean that's remaining? Well, what's remaining is just 3 minus I, and so that's what we are going to add to our count. And then we return this count at the end. Okay? So pretty straightforward. We just traverse. Whenever there is no match, we see what we need to insert, and then we insert it. And so we do only the bare minimum. That way we get the minimum number of characters we need to add. Yeah, so that's pretty much it for the solution. Let's implement it and make sure it passes. Okay, so let's implement what we saw in the overview. So what we need first is we need our string ABC that we are checking against, and then we need I pointer for S, and we need the overall count that we add. And so at the end, we need to return that count. And then we need to go through the letters in Word. So this is going to be just the range of Word, like this. And then we said we are going to keep checking while S of I, while it's not matching, that means we need to insert to get ABC. So while that's not the case, we want to insert, and so every time we insert, we increment the count because that's a character we are adding. And then we want to advance our pointer, but we want to use modulo 3 so that if we reach the end of ABC, we want to go back to A. So modulo 3 here. And now we said also we want to do this increment here because that means we found a match between SI and word G. And so we want to go to the next character in S because that match was already found, right? And so that's what we do here. And then at the end, if I at the end is different than 0, that means we found a partial match for this. Maybe we found just A, maybe we found just AB. And so we just want to increment to, if we just found A, that means we need to add BC. If we found AB, that means we need to add C. So we want to just add that here. And what's the thing that we need to add is just the remaining portion. And so we already found I, and so we need to add 3 minus I. So that's what we do here. 3 because it's the length of S. And that's pretty much it. And so we can run this. So there is this +1, of course. Submit. And it passes our test cases. Okay, so now what's the time complexity here? Well, for this, this loop runs the length of words, so let's say that's n. Now, how much does this run? Well, this we can add at most. How many ABCs can we have? Well, at most it will be as much as the length of n, right? So overall, this and this shouldn't run more than 3 by n, because at most we will have n ABCs. We can't have more. And so this overall is O of n time. And then in terms of space, it's O of 1 because we are not really using anything extra except these variables. So it's O of 1 space and O of n time. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.